Florence of the Renaissance. Scientists of the Del Cimento Academy decided to comprehend the eternal secret of the diamond. They focused the sun's rays on a diamond crystal in the largest and most expensive among the treasures of the Duke of Medici. The diamond smoked and disappeared without a trace. The truth was revealed only after centuries. The Medici Duke's diamond simply burned up like ordinary carbon. But it is known that graphite, as well as diamond, is also pure carbon. So maybe cheap graphite can be easily turned into a priceless diamond. Venerable scientists and amateurs have tried to repeat this masterpiece of nature. The diamond blinding lasted more than a century. And success came. We are his witnesses. These are artificial diamonds. In modern technology, they are called somewhat prosaic superhard materials. The capital of Soviet Ukraine, the city of Kiev, is 1,500 years old. But diamonds have never been found in its depths yet. However, it was here in Kiev that they learned how to make diamonds on an industrial scale. Institute of Superhard Materials of the Academy of Sciences of Ukraine. Almost all varieties of diamonds created by nature are obtained here. But unlike nature, where the process of creating diamonds goes spontaneously, scientists design diamonds purposefully. This work is based on fundamental scientific research, original experimental methods. For the first time, the properties of diamond became the object of mathematical and physical modeling. Scientists study the regular changes in thermal conductivity, electromagnetic properties, elemental composition and structure of crystals. Now it is possible to design diamonds using a computer and obtain crystals of the required shape and size. A high degree of uniformity, that is, with the properties that are set in advance. Each crystal acquires, as it were, its own face, hardness, strength, heat resistance. This allows you to choose the most suitable, optimal brand of diamond for any application. So, industrial synthesis. At the experimental plant of the Institute, it is called a reaction. Mixture of graphite with metal solvents is prepared. The mixture is placed in a chamber where the synthesis process takes place at high pressure and temperature. A few seconds of crystallization, and the process is finished. Get diamonds? This case became real only when it was based on a strict scientific theory. It is known that graphite and diamond differ only in the arrangement of atoms in the structural lattice. In order for carbon atoms to move from place to place, it is necessary to heat graphite to at least 2000 degrees. Then, the graphite must be compressed with a pressure of at least 60,000 atmospheres. And then graphite will definitely turn into diamond. This recipe for making a diamond, accurate and scientifically reliable, was written out back in 1939 year by the Soviet scientist the whole of Lipunsky. He constructed a diagram of the equilibrium states of the temperature and pressure system in which the real creation of a diamond can and should take place. This is how the field of industrial synthesis was scientifically determined. This theory underlies the creation of artificial diamonds by all firms in the world. An industrial synthesis technology has been developed. Machines give birth to diamond rivers of millions of carats. Then this stream divides into rivulets. Crystals are classified by type, size, shape, and grain composition. The process is carried out under the strictest control of electronic devices. Consumers receive a diamond quality certificate. Superhard crystals, born at the Institute, are able to displace natural diamonds from almost all areas of industrial consumption. Today, the trademark of the Soviet Foreign Trade Association machine import and the Institute of Superhard Materials is known in 40 countries around the world. Diamond powders with precision qualities with a grain size of up to 1/10 of a micron are also in great consumer demand. On the basis of submicropowders, finishing pastes are made for use in such industries as optical and electronic. Any processing process is a struggle. The winner is the one who has a higher resistance to abrasion, high temperatures, shock loads. The instruments in which these qualities of synthetic diamonds manifest themselves with maximum effect are also being developed at the Institute of Superhard Materials. The work of designers is automated. This allows us to fulfill orders for the design of tools in the shortest possible time, which the world market requires today. The effectiveness of the tool and the scope of its application largely depends on the ligament, elastic, galvanic, metal.
Гальванической, металлической.
You can fix the grains with rolled products and then make tools of any shape and size from such a flexible strip. In addition to this traditional technology, it is possible to associate diamonds with a chemical matrix. The grains acquire the ability to be held in the cutting layer exceptionally reliably until they are completely worn out. The method of sintering diamonds with a chemical bond of a vacuum furnace in the process of tool production is an original technology, and so far the only one in the world. Vacuum technology expands the capabilities of the tool and its application areas. The consumer can choose a tool with the properties he needs. There is no such area of human activity where synthetic and superhard materials are not used today. And everywhere they lead to revolutionary changes. Here are just a few examples from the many applications of diamond tools. Only a special drilling tool, equipped with inserts made of superhard composite materials, is capable of passing rocks under conditions of high impact loads. It opens the way for geologists to the riches of the Earth's interior at depths that are not yet available. Microsurgery. Steel needle holders hold the needle unreliably during operations on blood vessels and the heart. If the surface of the tool is covered with diamond chips, the needle is clamped tightly. It was believed that the diamond on steel does not work. However, the diamond tool, which experts called bars, effectively cuts not only steel, but also a whole package, with a set of the most heterogeneous metals. Kibarite and carbonite are new types of superhard materials based on diamonds and cubic boron nitride. In conditions when the carbide cutter, which was considered omnipotent until recently, does not withstand even 3 seconds, when processing particularly strong materials. The Kibarite cutter works easily and reliably for hours, maintaining its cutting properties. Kiev synthetic diamonds have even contributed to art. Gemstones seem to adopt a particle of diamond splendor. In the hands of the artist, the diamond tool reveals the essence of the stone, its true beauty. In order to exclude water leakage during operation of pressure-reinforced concrete pipes of water pipelines, they are treated with a diamond grinding wheel. This tool increases the processing performance of the docking sites tenfold, preserves the accuracy of the geometry. The headset made of Kiam diamond material does not require replacement during pulp grinding for several years of operation. And all this time, the stability of the technological regime in paper production remains. Diamond ring drills are almost 100 times more durable than hard alloy drills. When drilling reinforced concrete, they make even very hard work easy and simple. And this is also an original development of Kiev scientists. Granite blocks, like butter with a knife, are cut into separate plates with disc and strip saws. Diamond grinding wheels bring a ceremonial gloss, and shaped diamond rollers give marble the most bizarre shape. About 90% of the research and design works of the Institute are protected by copyright certificates for the invention. The institute holds more than 300 foreign patents, and its products made of synthetic and other superhard materials are exported to dozens of countries around the world. And it is not by chance that it has become a tradition for prominent scientists and businessmen in the field of creation and application of synthetic diamonds to come to Kiev to the Institute of Superhard Materials from all over the world. Says the participant of the Kiev Symposium, the president of the Belgian firm Diasem, Mr. Manfred Frankel. We have been cooperating with the Import Machine Tool Association and the Institute of Superhard Materials, Kiev, for over 20 years. The cooperation over all these 20 years has been good, and we hope that in the future, our relations with this institute will develop successfully.